Okay, can you see my screen again now?
Yes, I'm seeing your
Can you
screen.
see my screen? Okay, good. I've
Yes.
started the recording. Let's start this second class by reviewing what we've done in the first class. Then from there we proceed. Last class using this topology. You can see this. Can you see this lab?
Yes, yes.
Okay, good. So last class we learned about how to configure the interfaces, the joint between the router and the firewall, the joint between the PC and the switch, the joint between this server and the firewall. This place and this place are interfaces. And we learned that after the interface has been checked, has been configured rather, we need to check the status by doing show interface IP brief on the firewall. It will show you up, down, or administratively down. After that, we verify the direct connection by doing a ping from this firewall to this router to know if it's switchable. This firewall to this router to see if it is switchable. This firewall to the server. Let me scroll down. Yeah, to this server and if it is switchable. That is the first verification test that needs to be done. Thereafter, we configured a static route from this router towards this ASA. We configured a static route from this router to this ASA. We also configured a static route from this server to this ASA. We learned that the firewall does not inspect ICMP by default, but that it only inspects TCP and UDP, meaning that if you do a ping from this router to this ISP, right? It will be showing you um, it will be showing you that it's not ping, it's not reachable from this router because all what we need, that network person needs is if you are doing a ping from this router to this interface, you want to see exclamation marks that 5 out of 5 round trips is going through. But in this regard, we are saying that if you are doing a ping, is getting to this ISP because if you do a show connection or you do a debug on this ASA, you will see that the ping that you sent towards this ISP actually got to this place. And if you also do a debug on this ISP, you discover that the ping actually got there. But to verify, if you inspect ICMP on this router, you will discover that the ping will be successful, meaning that from the higher security level to the lower security level, traffic will be successful, right? But from the lower security level, which is the ISP, which because this G02 is the outside interface, this G00 is the inside interface. The G00 interface, after you have configured the security zones, remember that we talked about outside zone, DMZ zone, inside zone, and putting security level alongside those configurations. So when you are doing inside by default, the inside leg zone is going to give you 100, making it to be the highest security level, the most secure security level in the network. The When you apply zero outside interface, outside zone, it gives you zero, meaning that traffic from this level, outside leg, they are untrusted. So you have to do routing on this ASA to make them to be reachable. And on this DMZ zone, you have to apply a security level between 1 and 99. Am I correct? All right, so
Yes.
we will quickly again do the configurations again um, to remind ourselves then before we go to today's practicals. So in today's practicals, okay, let's do this first. Then we will once we now understand, we all remember this. We will now go. and to today's class. So I'm starting up these devices. You start them. I've already started them before the class. So I'm just double clicking on them to bring them up and start the configuration. R1, R2, ISP. Yes. Okay. The ASA is up. The R1. Can you still see my screen? Hello. 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 Are you there? Hello. Are you there? Can you hear me? Hello. Hello. Hello.
Yes, yes, I
Okay.
can hear you. Yes, I can hear
Okay.
you.
Okay. All right. So let's start today's. Let's start this. So like I said, when you bring up your ASA, there's no password by default, so you have to apply enter. To check the interfaces, so you can recall that we have four interfaces connected to this ASA. We'll be taking note of, we will not be configuring this management interface connecting to this switch yet. We'll be configuring these three interfaces: G00, G02, and G03. So to confirm the interface again, we do show interface IP brief. Okay, so you can see by default, all the interfaces are what administrative shutdown. So let's start. I will first configure interface G00. So you do config T, interface G0/0. No shutdown to activate the interface. Bring it up. Let's continue. All right. So like I was saying earlier on, with in the last class we learned how to configure the interfaces. So we want to configure the interfaces again here. Show interface IP brief. Please let me know if I'm too fast so that I can take it one as a step. Um, G00 is the inside leg, which is this G00 here, right?
Yeah.
Uh, if I should do a show run interface G0/0 now, this is all what I have. The interface no name if, so let's configure the name if. So you enter the G0/0 again, and we do name if. So you know what name if does now is the most secured interface, and automatically it gives this interface 100. So let's configure the IP address. The IP address is 192.168. So I'm talking about this, and this is 1/24. The interface connecting to the firewall is .10, so 1.10. Okay, then /24, which is 255.255.255.0. Yeah, so this is how to configure an interface. On this interface, we've applied name if and we've applied the IP address. Automatically, it has given it a security level of 100. So now we go to the G03, which is the DMZ zone. On a firewall, you don't need to do exit. You can enter any configuration at any place. So we enter interface G0/3, right? First thing you do is a no shot to activate the link. Here we will be doing name if, yeah, name if DMZ. Enter. Here you have to now come and do a security level on the topology. We have 60 security level of 60 to make it to be partially, secured. After this, we go to the last interface, which is G02, right? Interface G02, do a no shot. Um, let's give it a name if outside. The zone is not secured, it's the least secured. Automatically, it generates a security level of 0. So let's apply the IP address based on the topology. That is 101.1.10 dot 10 1 2 3 4. Then the subnet max dot 0. All right, so this is how to configure interfaces, which we did in our last class. The next thing after this, is to come and configure the interface of the router. So the router is already open here. I'm not too fast.
No, no, no.
All right, so on R1 now, close R1, I will launch again. R2, we will launch again. So R1 should be up by now. It's connecting. Okay. Deny connection. Okay, I see. I have some labs running. Just hold on. Let me close some labs. So I have more close lab. Um. Okay, I see. I need to close. Okay. Okay, I see. Okay. Let me stop this one. This is just SLA for this class for today, which we come to later on. Okay, good. It means one lab. Who is that? So let's continue. Okay, so let's continue our lab. Let me bring up R1 again. My ASA and the R2. Okay, my R2 is up. But before, we want to first configure our R1. To enter the router, you enter an EN, which is the EN. If we do a show run, you see that there's no configuration. Let's confirm that there's no configuration on this router. Okay, you can see the interfaces, they're all shut down. So I want to just verify that there is nothing on the router. Good. So there's nothing on this router. So let's configure this router. Like I mentioned earlier, it's good to change the host name of the router to what you have in your topology. To change that, you do host name R1. You can see that the name of the router has changed from router here to R1, so that when you are configuring, you know the particular router you are configuring. Now, I want to configure the interface of this router, and this interface is 00. I told you that if you want to configure an interface, you enter interface E0/0, right? Next, do a node shot to activate the link. Then you apply the IP address you have. You can see here the message on the router has already given you that the interface is up. So a firewall will not show you this, but a router will show you this. The IP address of this interface is what you have here, 192.168.1.1. The other end is .10 connected to the interface of the firewall. Must be on the same subnet as right? And because we've already, so to do, the next thing we do now is to do a static route from this interface, meaning that if there are some systems at the back of this router, when they will want to connect to the internet, right? When they want to connect to the internet, their gateway will be this interface, and their next point of connection will be where? Will be this interface. So we have to do a IP route 0.0.0.0. If we know the IP address, we don't need to do this zero. But what we are doing now is that we are assuming that we don't know what is behind the router, right? So anything coming behind this router should be forwarded to the interface of the firewall, which is 192.168.1.10. Enter. Okay. So from this scenario, what happened now is that from this interface, from this router firewall, we will be able to ping the router, the interface of this router, which is 192.168.1.1. Okay, sorry. I'm saying to configure, to test the reachability of the static route we've done, from the ASA, you will ping the router to confirm, you know, reachability. This router is 1.1, don't forget, and it's reachable. It's reachable. Now, before we configure the interface of this auto, let's see if we can ping the auto router. The auto router is 2.1. Let's see, let's confirm if we can ping before we configure. So you can see the firewall is saying that no route to where, to this router. Are you with me?
Yes.
Good. So you can see before we configure this router at all, when we initiate a
So,
ping from this
does that
ASA,
mean that does that mean that um, if we did not do the routing, pinging would not work?
um pinging will not work. Yes, pinging will not work. You will not be able to reach. You will not be able to reach the destination because the firewall is the source this time around, trying to reach the destination. Yes, pinging will not work. You will not be able to reach it. Either via ping, either via telnet or SSH, you will not be able to get there.
Uh, So that so that means it has to be routed for anything to go through.
Yes, it has to be routed for anything to go to, which is the work of the firewall. So anything you don't configure on this firewall, it will deny it. So that's why we are saying that ASA is a security future.
Okay, so that means if it is from router to router, there's no need for that routing command that we did.
If it is router to router, you do a VPN. That's where the site
Okay,
side VPN comes in place. But now we are still talking
okay,
about a firewall, a router to a firewall to a router. So we have to define the routing table, how you want your routing table to be able to move your traffic. Okay, so
okay.
let's move to how to configure how to and come
Oh,
and
sorry,
ping.
one more thing. If we do not do the routing and it is from router to router, and let's say let's leave VPN out. Let's say we want to ping from router to router, and we do not do that routing like we did for the firewall. Will it still go? Will the ping go or the telnet go?
So are you saying that the router is in the same location and you are connecting them together directly?
The way we just connected this R1 to this ASA. Let's say we remove the ASA and connect it directly to the ISP, and then we now
Directly
ping
to the
ISP.
ISP.
Yes, we now
Okay, I
ping
get you.
ISP from R1.
So you'll be able to ping it because it's a physical interface. You are connecting the physical the ISP is bringing is providing you a service, is providing you internet, and is connecting is fiber cable, network cable, whatsoever means to your router. So it's a point to point connection. So you'll be able to ping it because you are pinging. So let's assume this is the as you can see here, yeah, this is the ISP, right? This is the ISP, right? This is your ISP router in your office, right? This is let's assume this is 21st century. 21st century run a cable inside your building. This cable is going to land on where? On your physical router. So because it's landing on your physical router, they will assign an IP address on this interface. Am I correct? So on this router, if you are pinging this physical interface, which is your gateway to reach the internet, it's going to respond because it's a point to point connection. Am I able
Okay.
to answer your question?
Yes.
Good. All right, let's continue our podcast. So now I'm bringing let's configure how to. Then after configuring how to, we will do the ping again from the ASA and let's see if it's going to respond. Hmm. Can you still see my screen?
Yes. Yes.
Okay, I'm refreshing the page. Hold. Okay, so how to how one. Okay, so for how to change the host name to host name how to. Okay, the interface of the how to is E00 interface E0/0. No short to activate the interface. IP address you can see it has sent a message that yes the status protocol is up 192.168.2.1 255.255.0. Now the next thing we have to do is to do what? To point a static route towards the ASA. That is IP route 0.0.0.0.0 192.168.2.10. the interface of the firewall, right? Which is the DMZ. Remember, this is the DMZ zone. So let's go back to the ASA and um, ping. This is the ASA, the 2.10 interface, and pick backward to see if the ASA can reach the out2. Why? Let's confirm the show name if the configurations we've done on these interfaces are still there. This is G03 show run interface G0/3. So can you see what has happened? Hello, are
No
you there?
IP address.
No
Yes.
IP address. That is good. That is good. So there's no IP address. That is why the ping failed from the ASA to the host. IP address 192.168.2.10 55.55.0. To confirm again, let's do a show run interface G0/3 to confirm that it took that configuration. Now let's do a ping again from the ASA to good to the out2. So can you see this? Can you see this?
Yes.
So there is switchability between the firewall out to R1, the firewall to R2. So let's confirm again if the configuration facing R1 is also still there, show interface G0/0. Okay, so that is still intact. So now lastly, to configure the last interface, will be we've configured this interface. We are now going to point towards the ISP. Okay, so let me do this. Let me do this. Yes. So now the interface of the ISP, we want to configure the ISP now. We've configured this interface, right, for G02. Let's confirm show interface G0/2. Yes, we've configured this. So we have to configure the ISP now. Let me drag down. Um, Let me refresh this lab. Okay, so let's configure the ISP. Let me close the ISP again. Let me just confirm if the configurations of the R1 is still intact. ESC. We have to confirm the RAM that was allocated to these devices. If not, I need to increase it. So let's do this. I will shut down the ISP and bring it back up. So the ISP. Okay. The R2 and R1. Okay. I think there are some labs that are still on. So the ISP router is on. So let's wait a few minutes for it to boot. Okay, so the ISP is up. Like I said earlier, host name, ISP is connected to interface E0/0, no short, IP address 101.1.1.1 255 255 255.0. Then we also will do a IP route to point it back to the firewall. IP route 0.0.0.0 1 101.1.1.10. Okay, so if we come back to this ASA to confirm reachability, we'll be able to ping the ISP router 101.1.1.1. So you see. So now what this says is that the ASA knows how to reach here, and know how to reach here. So let's do show out. To confirm all the statements, show out. And see that these are the direct connection to the ASA 101.1.1.0, which is the outside leg interface, which is this interface G02. You can see that this is the this is still the same subnet as the first one. This is the route to R1, which is inside, okay, which is this interface here, and this is the last interface pointing to R2, the DMZ zone, the DMZ zone. So we have the DMZ inside and outside. Those are the only routes that the ASA understands at this time. And if you recall again, I mentioned that by default, the ASA does not inspect ICMP. So, so before I do this,
What does ICMP stand for?
ICMP is a protocol. It's a protocol. So this is R1, right? So if you want to check the if you want to confirm that this R1 can reach this interface, right? You put 192.168.1.10. Am I correct? So it's a protocol. It's a protocol. So you can see here sending ICMP echoes. So the ICMP is a protocol that is used to confirm reachability. It sends packets. It sends packets and confirm if there is reachability between two hosts. That is what it does. It's a protocol. Another protocol apart from ICMP is Telnet. Another is SSH. So if you recall in the last class, I brought up PuTTY. You can still see my screen, right? So
Yeah.
here you can see that another protocol is SSH. SSH uses port 22. Telnet, which is another protocol, makes use of what? Port 23. So what this talk says is that if you put the IP address here, right? You pick Telnet or SSH, right? By the time you open, this protocol is going to send a request to where? To this 1.10. So it's a form of reachability. So apart from the Telnet SSH, another protocol is ICMP. So we are saying that, so now assume that this R1 want to reach this ISP, this interface to browse. You know, the essence of having an ISP here is for the users to be able to what? Browse the internet. Am I correct? So for my PC,
Yeah.
I enter www.google.com. I'm sending a request for my PC, and that request is going straight to the internet to find where google.com is, and Google, the site I'm accessing, gives a return back and open the page on the system. So that is what happens. So now we are saying, I'm saying that if you we ping the ISP now on this R1, I'm on R1, I'm on this router now. Let's see if we can ping the ISP, and the IP address of the ISP interface is 101.1.1.1. Yes, you see, you see this. This is showing that it's not reachable. Am I correct? But I'm saying because this zone is what is a inside zone, is the highest security zone, is the most trusted zone. Traffic from R1 to the outside lane is going to be reachable. So now we've done a ping. You can see that it's not responding, right? On the ASA, on the ASA, if we should do shocon, you see this? The shocon, let me explain this. This is showing that on the ASA that the destination is what? 10.1.1.1, which is the ISP, is saying that the source is from the inside, which is what? 192.168.1.1. Who is 192.168.1.1? Is what? R1. R1 is trying to reach 101.1.1.1 and is reaching it. Is not giving a response that is reaching it because this firewall is not inspecting ICMP. So can you see this? These are what the ASA these are what the ASA inspects. It inspects FTP, it inspects all these protocols here, all the protocols here. So what we need to do if we want the ASA to inspect ICMP, right, is to come and inspect ICMP. You can see how I'm trying to inspect ICMP. ISPE, okay, inspect ICMP. Okay, let's do this again. I will teach you two ways to inspect ICMP. Let me check what I've done here. Okay, so this is what we do. You copy for the global config policy config. Okay, then INSPECT. You can do question mark, right? Okay, inspect ICMP. Okay, so now we've added ICMP. So if we should check, if we should do, let me do show one. There's a way to check to navigate to where the policy is directly. Let me just do show one. Where, up to where we have the global configuration, you will see that you see this ICMP is now being what? Inspected. Okay, ICMP is now being inspected. So if we should go back to R1 and ping the ISP again, you will see that it's switchable. Do you understand? So from the
Okay.
higher security level, which is inside, to the lower security level, traffic is allowed. That is why the security level is 100. But the ping is not showing this exclamation mark because the firewall is not inspecting ICMP. The only thing it's inspecting is TCP and UDP. Another way, let me quickly tell you another command. If you don't want to come through this place and put this, another command to use to inspect ICMP on a firewall. Let me exit this place. The lab is slow today. Is to do is to run this command fix up. Yeah, fix up. Let's see available commands you can use. Okay, I see. Let's refresh this lab again. Fix up. And I'm refreshing the lab again. It's slow today. I think there are some labs I'm working on that I didn't close. It's making it to be slow. Come up, come up, come up, come up. We've used 36 minutes, so I think this is the last leg of what we've done last class. We will configure once it comes up now. We will configure telnet on the ISP, and we will jump over from the we will initiate telnet from the R1 to the ISP and see how you can use telnet to jump over in the network. Then from there we go for today's class. Okay, it's up now. So I was saying that I want to show you another command to use to inspect ICMP on the ASA. So most times, right, when you want to ping probably your ISP, it will not be reachable. It does not necessarily mean that um your your ISP is not reachable just because your firewall is not expecting ICMP. So like I was saying, you run this command, fix up protocol ICMP. Okay?
Okay.
Yeah. So you do this. If you could run this command on your ASA, what you are telling the ASA to do is that it should what? It should inspect ICMP. So doing this also It's going to add this ICMP to your what? It's going to add it under the global configuration. Yeah. So now let's configure. Let's configure telnet on this ISP so that from R1, before I configure telnet, let's do this. Let's do a telnet from the R1 to ISP. Let's see if it's going to go. Then if it goes, we will not bother to configure telnet again on ISP, but we need to configure telnet because you want to secure your network in such a way that when you try it, if that means that if anybody do a telnet to in your network, it will not ask for username and password. Remember, we've not configured username and password on these routers.
Yeah.
Okay, so do. Hold on, it's not come up. Let me close R1 again. Bring up R1. Close R2. Close ISP. Rather, bring it up again. Now R1 is working. So these are just one or two things you need to know when you are working on these labs and performing this. You close, you open again to refresh. Cannot read properties of reading name. Okay. So the ISP is coming up. Okay, simultaneous connection. So you know what I will do? And I didn't save. I'm going to shut down to have more resources to be able to work with. So let me shut down Auto. I will reconfigure Auto. Let me shut down this switch. I don't need this switch for now. Let me also shut down this PVC. I don't need it for now. Yes. So I think I should have enough resources to work with. Okay. Let's refresh the lab. Let's refresh the lab. So okay, are you there? Are you there,
Yes.
Solomon?
Yes.
Hello,
Hello. Yes.
hello,
Yes. I'm with you. Hello. 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 Hello.
hello,
I'm with you. Hello.
hello, hello,
Hello. 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 Hello.
hello,
Hello. 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 Hello.
hello,
Hello. 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 Hello.
hello.
Hello. Hello.